All right, so specific heat. Does everything heat up and cool down at the same rate? What do y'all think? All right, good. So different substances have different capacities for storing energy. It can take 20 minutes to heat water to 75 degrees C. The same mass of any metal could only require 5 minutes. So different mediums require different amounts of heat to change their temperature. The reason for that is because of specific heat. So specific heat, I want y'all to write the definition for it. Specific heat is the amount of heat needed to raise the temperature of 1 gram of any substance by 1 degree Celsius. So the amount of heat needed to raise the temperature of 1 gram of any substance by 1 degree Celsius. So the higher this number, the more energy is required to heat that thing up. The lower this number, the more quickly that thing gets really hot. So the thing with the lowest number on this list is going to be gold, 0.13. That means gold will get really hot really quick. That's why gold is such an excellent conductor. That's why your HDMI cables, your really good HDMI cables, are gold plated. So silver is also pretty good. Not as good as gold, but it's pretty good. But here's water. Water is the thing we're going to be working with the most. Water has a specific heat of 4.18. We talked about how the specific heat of water being high is very important to the planet because the ocean absorbs so much of the heat in the environment and it keeps the planet cool. So living close to a lake, it doesn't get as hot because the lake, it absorbs a lot of the heat that the sun gives off. Air is... water requires 4 times as much energy as air to heat it up. So air gets hot pretty quick. Let's move on. So next we got a couple definitions. So conductors, we know what conductors are. Conductors are materials that transfer heat easily and quickly. You can write this if you know it. There's no need to write it. Remember, metals are the best conductors. And the reason they're good conductors is because they have low specific heat. That means they absorb heat very easily. So the opposite of a conductor is going to be an insulator. Insulators do not conduct heat easily. They have a high specific heat. Examples of insulators are going to be things like water, glass, plastic, rubber, and air. Water is not an insulator when we're talking about electricity because you've seen electricity conduct water. Or sorry, water conduct electricity. But water will insulate heat. That's why engines run water to keep the engine cool. Materials that trap air, such as foam, fur, and feathers, are the best insulators. Who here has ever used a Yeti, like one of those Yeti coolers? All right, you've seen those coolers. You put something in those, and it stays cool all day. That's because of the design and all that air that's trapped on the inside. That air is a very good insulator, and it'll absorb a lot of that heat. Keep it from entering your box. All right, let's move on. All right, so don't worry about this. Here's our formula. So let's all write our equation, and then I want us to define the equation. So Q is going to be the heat energy. This is where our joules go. M is going to be the mass of our substance. Make sure that it's a lowercase m because capital M means something completely different. So lowercase m for mass. And then most likely this is going to be plugged in as grams. So Cp is going to be our specific heat. Our specific heat has a weird unit. It's going to be joules over grams times Celsius. Joules over grams times Celsius. And then delta T. Anybody remember what delta T is? It's the change in temperature. And the change in temperature is going to be put in Celsius. So you don't need to convert to Kelvin here. All right, so this formula is very often referred to as MCAT, and the way to remember is anytime you're talking about heat, you're going to use the formula Q is equals to MC delta T. So MCAT. Now let's go ahead and practice with it. Here's our first problem. How much temperature can be expected? How much temperature change can be expected when 250 grams of water absorbs 50 joules of heat? So let's go ahead and write out our formula. So Q is equal to MC delta T. So we're solving for temperature change. They give us our joules. So that's going to be our Q. And that's going to be 50 is equal to 250 grams. And we're talking about water here, so we need the specific heat of water, which is 4.18. And then we're solving for delta T. I'm just going to plug in an X. So how do we solve this? What's our first step? Multiply what? 250 times 4.18, and that gives us 1,045. And then these go away. And now X times 1,045. What's our next step? All right, so we're going to isolate our variable. So 1045. This goes away. And 50 divided by 1045 will give us 4.83. So our temperature change is 4.83. And then that's going to be in Celsius. Was that easy? All right, so let's try the next one on our own. All right, so 15.75 grams of iron. I'm going to start by writing my formula. So Q is equal to MCAT, MC delta T. So Q is given to us. It's right here. So 1086.75 is equal to 15.75. And our temperature changes from 25 to 150. We're solving for C here. I'm just going to put an X. And our temperature change is 150. So what's our first step here? What's our first step? So 15.75 times 150. Uh, 2,362. Is that what y'all got? 2,362. Did somebody get? That's what y'all got, right? All right. So X goes here, and then what's our last step? We're gonna divide both sides by 2362. This goes away. So 1086.75 divided by 2,362.5, and then X is going to be equal to 0.46, and let's see if that's correct. So over here it gives us iron, which is 0.45, which is close enough. So our X is our CP is equal to 0.46. Who else got 0.46? All right, good job. Last one, and then y'all can turn in your notes.